Good morning, everyone. My name is José. Welcome to Nightmare Before Best Practices. Now, just before I start doing this talk, don't forget to rate the conference talks. If you enjoyed this talk, after it's ended, just go on the app and just rate I enjoyed it. If you don't enjoy this talk, don't bother, that's okay. Just to get it out of the way, my name is José. I work at Codacy. I am also a magician and a card cheater. I can say this in public because I don't actually cheat people for money. I do gambling demonstrations. If you come and find me in the hallway later on, you are entitled to a miracle. Just meet me and say, I want my miracle. And this talk is not about Codacy, but just so you know where I come from. Codacy is an automated code review tool. It integrates with Git. It supports a number of languages, Scala being one of them, of course. It's free for open source projects, and you should totally check it out. In fact, this is where we are right now. And there's a talk in the afternoon by Eugene. He's going to mention Scala Meta and maybe other things as well. And we actually use Scala Meta for the Scala static analysis that we do. So I totally encourage you guys to go and see that talk as well. But today, I am going to tell you about nightmare scenarios. So the inspiration for this talk comes from another talk that I saw a couple of years ago. And a friend of mine was doing that talk, and he said that whenever we go to a conference, we always share our success stories. We're always talking about everything that went right, how we solved problems. We're never talking about how we created the problems in the first place. And we could learn a lot from each other by sharing our mistakes. So with that in mind, I am going to share with you 5 nightmare scenarios that actually took place because best practices weren't in place. And then I'm going to talk a little bit about some best practices that I feel that we all should use. I should add that all of the events in this talk took place exactly as I'm going to describe them. The only thing I'm omitting is the name of the companies and the name of the people involved. And with that said, here's nightmare number 1. The developer lost 180,000 euros. So there's a new website with a shopping cart, and there's payments, and there's a successful launch. And everything works, and everyone is happy until 3 weeks later. 3 weeks later, the developer on the project actually makes a purchase on the website himself. And he receives the product, and then he goes to check his credit card account, and he doesn't find a charge. He's a bit worried, so he goes to the back office, and he realizes that there haven't been any charges at all for the past 3 weeks. But they have been selling a lot of stuff. They've been selling 30,000 euros per week. So that's 90,000 euros that they haven't charged the customers. So they get in touch with the payments platform, and they ask them what's going on. And they say, well, there are 2 ways of charging customers. And they could have added, you're not using any of them. So way number 1 is you just charge the customer. It's a simple call to an API, and you just charge the customer. The second one is first you request the credit approval, and then you charge the client. You may be familiar with this. These are 2 operations. Whenever you book an hotel, for instance, they're not going to charge you right away, but they're going to pre-approve the credit to make sure that you have the money to pay when you're done. But then they added, by the way, after you get the approval, you have 1 week to charge the customer. So 2 weeks of money already down the drain, and 1 more week that they may lose. This is about 4,000 euros per day. Every day that passes now is going to cost them an additional 4,000 euros. This guy doesn't make that much in a month. Did I mention that this took place in a Friday afternoon? I didn't, did I? I didn't because it actually didn't take place in a Friday afternoon. It was Friday evening. So at 4,000 euros per day, we're looking at a potential 13,000 euros for the weekend. So if it doesn't solve this problem right away, but he has a train to catch. I'm not kidding. The guy had a train to catch. And I did mention that the guy lost 180,000 euros, and so far he's only lost 90,000. Enter the words, you can use this code to fix that. So somebody handed this guy a script and said, we had a similar problem in the past, and this is how it solved it. You can use this code, and it'll solve it. And the guy did that, and he thought, well, if I'm going to run this over the transactions of this past week, I can actually run this for the transactions of the 3 weeks, because who knows, maybe it will work. So he goes for the weekend, the code is running, and Monday morning he goes to check his credit card account, and finally, there's something, it's the right amount, and unfortunately, it's a refund. During the weekend, this guy issued 90,000 euros in refunds. This is the best product launch ever, you know? And that's how the guy lost 180,000 euros. But why? You know, in the API of that payment platform, there's a bunch of calls, and unfortunately, they all link to the same endpoint. And that endpoint takes all the information that you give it, and there's one action ID that tells it what you want to do. So it took a script that no one had touched for a bunch of years, and the script was doing refunds. So the guy changed the endpoint, but he had no idea that he had to change the action ID. And that's how he lost 180,000 euros, or almost. I mean, the guy did lose the money, but then the technical project manager got in touch with a payment platform, and he blamed them for this. And those guys actually managed to solve the problem somehow, and they managed to give us all the money back. What caused this? No serious testing on the project, absolutely no code review on the script, obviously undocumented code on the script, releases on Friday, although in the guy's defense, he had to do something. And by the way, bonus tip, last week I found out that it is only okay to do a release on Thursday as long as the following Friday is not your national holiday. And never, ever run untested code. Nightmare number 2. Supple Code Bits was a conference that I helped organize for a bunch of years. The conference is coming back this year with a different branding. If you're interested, talk to me in the hallway. So we're talking about 1,000 attendees that don't pay a thing to be in, but they have to apply to get inside the conference. So we get to approve people, and that's how we ensure that we don't get managers, recruiters, non-technical people. We choose the most motivated, the people with most potential, people who are actually going to take something out of the conference. And the conference lasts for 3 days, 24 hours a day. The doors don't close. There's a bunch of stuff going on. There's a quiz show, presentation, karaoke, lightning talks, etc. But at the very core of the event, there's a 48-hour competition. So about half the attendees gather together in groups, they build something, and at the end, they have only 90 seconds to present. And the whole attendees, the whole attendance get to vote on those projects. And this is a nightmare in 3 chapters. Chapter number 1, the visitor. The doors open. People start getting in. And after a while, I go to the back office. This is a very simplified version of our back office. And I do a search, and I find myself, okay, I'm approved, I have checked in. I see our CEO, who's been approved, and he hasn't checked in, even though he's been in the building for about a week now. And then I find this guy, a guy who has not been approved, but still managed to check in. This guy was actually a security expert who doesn't have a lot of information on him online, and he didn't want to provide that information to the event, but he still applied. He was declined because we had no idea who the guy was. But he decided to show up anyway. He got to the registration counter, he provided his name, someone did a quick search, his name showed up, there's a tiny badge on the bottom right corner that said rejected. The person didn't even realize that. The person clicked the check-in button and everything worked. So the guy gets in, and for the next 3 days, he's totally silent on LinkedIn, Twitter, Facebook, everything. There's no movement. We can't find him. We don't have a picture of the guy. We have no idea where he is. We only know that he managed to check in. This is a potential problem for us because pretty much everyone inside the building has a friend who was not accepted. So the moment those people find out, they're going to be angry. And also, if he starts telling all his friends that this works, we might have a situation in our hands. Chapter number 2, the anonymous tip. This is a profile on the CodeBits website. This is the back office for editing that profile. You can change pretty much anything. And a few days before the event, a guy sent us an email saying, I am really pissed, I have to share something with you because some of my friends were not approved. That's okay. But I know these two guys, one of them was approved, the other one wasn't. The guy who was approved is not going to be able to make it to the event, so they're going to change the name and the picture of his profile. Really clever. We ended up sending an email to those two guys. None of them showed up. But still, it's a security vulnerability. We have no idea whether someone did this before. Chapter number 3, voting. So at the very end of the conference, you get people on stage presenting a project. This here shows you that there's 4 seconds left to vote. This group so far has gathered 80 votes in favor, 49 votes against. And this is part of the audience. Now, at 90 projects, 90 seconds, that's over 2 hours of project presentations. And we want everyone to vote for all of them. But that's a really, really long time. If we factor in 10 seconds, just 10 seconds to vote, that's 15 minutes more. And guess what? The guy who built this part, he only tested with 1 person voting at a time. Yeah, so on the very first project, the site went down. So there's people hacking live, solving the problem while all the attendance is waiting, and they managed to fix it. But at the end, we got a few problems. An unauthorized entry, at least one, some security flaws, and a website down. And it's interesting because the causes for this are no tests, well, the specification didn't account for security issues, and no stress testing. What's funny is that we had a quality assurance team, we had a security team, and we had a team specialized on doing stress testing. But, but the thing is, this wasn't a real project. So this was just an event that we were putting together. So we tried to keep it on as low a budget as we could, and that's what we got in return. Nightmare number 3. Switching services, and this is actually a nightmare that took place before code started being written. A travel website, it's based on a specific content provider. There's countries, there's cities, so basically travel destinations, and there's photos of those destinations. And we did the technical specification for the project. We prepared the roadmap, we prepared everything, we had the deadline, we announced the project, and then somebody said, let's use a different service for the photos. I don't really like the photos from our partners, so we're going to use these other ones because I like those photos best. The problem is our partner had location IDs for the travel destinations, and the new service had GPS coordinates and a location radius. And everybody said yes because no one had realized this. Now we need to convert from one thing to the other. There's 2 schools of thoughts. One is based on centroids, and the other one is based on the central point of interest. If we take a look at centroids, and taking a look at Portugal, for instance, where I come from, that over there is the center of Portugal, and here we have the capital, Lisbon. So if you want to show relevant pictures of the country, you have to use a location radius. But before you get to the capital, you get to Spain. If you use a small location radius, the photos you're showing might not be that relevant. In the case of Portugal, at the very center of our country, we have this. This is actually a monument that marks the center of the country, and many countries have something like this. So what if we use the other school of thought? The other school of thought goes to the capital. If you look at the GPS coordinates of Portugal, it gives you GPS coordinates inside the capital, Lisbon. Now, if I'm going to show you pictures of Portugal, and if I'm trying to get you to do some vacation, sightseeing in Portugal, this is what I'm trying to show you. I am not trying to show you this street that I have never been to. And back then, I decided to go on Google Street View to see what these kind of coordinates would give me. In the case of Lisbon, this is what you get. Which is not bad if you look at the other side of the street. I did some search. I found out that at the very center of Spain, for instance, they sell electronic equipment. I found out that the very center of Finland and Brazil look very much the same. But what I really wasn't expecting was to find at the very core of Japan a freaking elevator. Japan, you know. But on closer inspection, that really isn't an elevator, because there's a door handle here that says staff only. That's an emergency exit. So at the very center of the country, they have an emergency exit for staff only. The problems here were wrong time estimation, additional technical issues to solve even before we started coding, and a tech team unable to meet the deadline. And guess what? The project never launched. Because this wasn't the only change that was requested. And the project was aborted, and then later on another team picked it up with a different specification, and then they finally managed to do it. What caused this? Well, changes in specification. And I know, agile, 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 but just because you're agile doesn't mean that another team gets to gather in another room and decide what you're going to do with the same deadline. Nightmare number 4, also in 2 chapters. And the first chapter is called The Laptop. Another payments platform, and everything was working for a while. And then the developer goes on vacation. And then this happens. Somebody closes that guy's laptop. And unfortunately, the guy didn't believe in cell phones, so he couldn't reach him. And guess what? On that guy's laptop, there was an SSH tunnel connecting 2 production servers. So when they closed the laptop, no more payments. Fast forward a few years. This time we have a newsletter platform. And there's a new product, a new client that has a new newsletter that we have to put inside our platform. And that's okay. We're ready for that. Although we weren't ready for 250,000 subscribers that have to receive the newsletter in less than an hour. And in fact, that was the compromise after a few meetings. What they wanted was that all of them would receive the newsletter precisely at 1 o'clock. And we asked them why, and they said because the product is called at 1 o'clock. So they wanted people to read their newsletter while they were having lunch. And our platform wasn't able to do that. So enter the words temporary solution. Let's build something, a different newsletter platform just for this case until we fix our big platform. So the newsletter goes live and everything works because the 2 guys doing that, they were really good and they managed to do a newsletter system, an email delivery system that was really, really fast. And then somebody goes on vacation again. And then there's no newsletter. We checked. The guy didn't have a laptop. We went into the production machine because there was no documentation. And we went to look for the processes that were running. And instead, we found a screen session, which is never a good sign. We had no idea of knowing what was inside the screen session, but we could check his bash history. So we could see what kind of comments the guy was running. And that took us to a database. And on that database, this is what we found. We found a couple, I knew that the newsletter had 3 different segments. So we found for each day 3 records for the 3 different segments. But on that day, there was something else, something called segm. And there's a status column with a D. And I figured it might be delivered. So I figured, let's delete this row. The extra one. Hold on, it worked. The newsletter was sent. Suddenly, everything was working. Why did this happen? Well, obviously, the system stopped because it couldn't handle that line. But the reason that this worked, this happened, was that with the words temporary solution, instead of having a combo box or something like that to select the segment that you're delivering to, there was a text field, a text area. And the reason that the platform had been working until the guy went on vacation was the same reason that the guy had stopped having lunch with us. So every day around 12:30, the guy was sitting at his laptop waiting for the client to make a typo, and then he would fix it. Temporary solution, you know? So in one case, payment stopped, and in the other, a newsletter wasn't sent. Why? Because of the absence of deployment methodologies, and also lack of documentation. Now, I would imagine, I see people nodding all the way, I would imagine that most of these best practices, even if you don't follow them, you're aware of them, right? Here's a nightmare that took place before Git and SVN were around. So the code was on CVS, but not all of it. And the rest of the code was on a file system, the production file system, which was also a shared file system. And there were snapshots of the system, daily snapshots. So everything was working. This was a big project. We had moved a sizable team from Portugal to Brazil to do this for over half a year. But on the same file system, there was a webmail platform. And that platform was getting slower and slower. And the guys who were handling webmail were looking for a way to make it faster. And then one of the guys says, oh, look, snapshots. We don't need these. We can turn them off. And they do. And we don't realize that. And a few days later, somebody is upgrading the server. And when deleting a folder, they make a typo. And they did this as root. So suddenly our code was gone. Now, at 6 a.m., everybody got a wake-up call, an early wake-up call, calling everyone in for an emergency meeting. At that emergency meeting, everyone was making excuses. Everyone was explaining how this was not their fault. Everyone except one guy. That one guy was the one guy who got late to the meeting with a huge smile on his face. And when they asked him, what are you smiling about? He said, I just fixed the problem. You see, the code was deleted, but the code was still live on memory. And these were templates. So the guy did a dump of the whole memory. He gathered the team in a room. He coached them for a while. And he taught them to fetch the templates from the memory. And after a while, he had the code back with snapshots. Why did this happen? The lost code. The causes are slightly different from the previous nightmare scenarios. Untested data recovery procedures. You turn on the snapshots and you forget about that permanently. Resource sharing between projects. And also abusing credentials when you're dealing with production machines. I should add that this guy is currently working on Google's site reliability team. Now, these scenarios, everything here happened for a reason. A list of best practices, that would have to be a really big book, but if I could only mention a few, these would be technical specification. So before you start, you should know what you're doing or what you're aiming for. Some kind of coding standards to ensure that your code is readable, maintainable, less prone to errors. Code review, obviously, and I'm referring to both peer review and automated code review. And I know that I might seem biased because I actually work at an automated code review platform, but it's not like I'm trying to pass any kind of subliminal message here. But just in case you missed it, that's... And also testing, all kinds of testing. Some kind of deployment methodology that really works, and also technical documentation, not just writing it, but also having the habit of looking for it when you get into a project. Now, there's two more things that I want to tell you about regarding best practices. The first one is that best practices are different from language to language. If we look at static analysis tools from different languages, we will see that patterns are different. Sometimes there's a reason, sometimes there really isn't. Something like a to-do comment. You've probably seen to-do comments or fix-me comments, right? The patterns to look for this are different from language to language. If you look at Java, it's pretty simple. It looks for fix-me and to-do. And it raises a warning, says, you shouldn't have this. If there's a fix-me, then your code isn't ready. If you look at Scala, it's similar, but now it gets case-sensitive options. If you look at JavaScript, you get to-do, fix-me, XXX, case-insensitive. You get an option to search for these elsewhere in the comment, not just in the beginning. But if you look at Ruby, you get something different. So instead of raising a warning, there's only a convention to make sure that you're writing those comments properly. If you get a broader look, and if you look at comments, you'll see that these are very, very different from language to language. In Ruby, there's a pattern that I haven't found in any other language to ensure that your comments are written in ASCII. So no hiragana, katakana, kanji, nothing like that. And it makes sense because the language comes from Japan. And in other languages, this probably wasn't an issue. You'll find a pattern to prevent block comments and also a pattern to prohibit inline comments. I guess you have to choose. And also a pattern to enforce a leading space on a comment. And I'll show you in a bit why this is important. If you look at JavaScript, it's different. It's going to enforce empty lines around comments. You get to prohibit inline comments again. The warning comes, the to-dos and fix-me's. And now you get another pattern for spaces in the beginning of comments, but you get to choose whether you're enforcing them or preventing them. So clearly, best practices are subjective. If you look at Java, there's a bunch of stuff. It's really different from the other languages. Some of them are specific to the language. And there's even a pattern to prevent politically incorrect comments. This actually prevents you from writing something like, whoever did this was an idiot, which tells you a lot about a language. I'm kidding. How many of you are familiar with best practices for regular expressions? It's not something very common. One person. If you look at Ruby, there's only two patterns that I could find. One of them is to prevent some ambiguity when you're reading the code, and the other one is to prevent denial of service attacks. So to prevent that you're using part of the user's input and placing that in a regular expression that you're using somewhere else. This isn't present in many other languages. And the reason for that is probably that these guys, probably due to a really cool framework that they have, they found this problem quite often. If you go to JavaScript, it's completely different. You're going to get these kind of patterns, for instance, prohibiting invalid regular expressions or malformed regular expressions. And there's a reason for that. The reason is that the code is not running on your servers, it's running on the browser, on the client side. So if it's broken, you're not even going to see that. So if you're not compiling your code before you're shipping it to the client, at least the static analysis tool is going to look at it and it's going to tell you, hey, this should be fixed. And then there's a few other things. If you look at Java, it's completely different. For instance, a file separator, it's a variable that is different on Linux systems and Windows systems. So it's going to warn you, your regular expression is going to differ from system to system. If you look at Python, oddly, this is the complete list. There's no particular reason for that. I know because I spoke with the main maintainer of Pylint. There's no particular reason. It's just that no one has found the necessity of building those patterns for regular expressions in Python, which brings us to Perl. I apologize in advance for the font size. Okay, this is more readable. The thing is, many of these, most of these, almost all of them, they make sense in other languages as well. But these guys have found this more often. Some of them have to do with the readability of the code. Some of them have to do with performance. Some have to do with possible typos. Some of them, like this one, for instance, prohibiting unusual delimiters, this is specific to Perl, because instead of having slashes delimiting your regular expression, you can have pretty much anything else. You can have the pound sign if you want to. And that is useful in some cases. Like if your expression has a lot of slashes, this way you don't have to backslash everything. But in terms of readability, it's not that good. So the first thing I want you to take from this talk is that best practices do change across different languages. That's not a bad thing. You can learn a lot by looking at what other languages are doing. But even in the same language, if you take a look at Scala, and if you take a look at a few style guides, the Databricks Scala style guide, which is interesting because these guys, with over 800 contributors, they really have to make sure that everyone is writing the same kind of code. The Scala style guide, Effective Scala from Twitter, and also PayPal's Scala style guide. And by the way, just a side note, if you happen to use Codacy, you can actually select those style guides. They are not comprehensive, but most of the rules, if we have them, they're going to be displayed for you and you can enable those standards. But all of these standards, I can tell you right now, they're all good, but they are different. Something as simple as a line length. Databricks imposes a maximum of 100 characters. If you go to Scala Style Guide, you're down to 80 characters. If you go to Effective Scala, you're back at 100. But if you go to PayPal, it's like they're saying, we have more money for bigger screens. It's different, you know. It depends on what your environment is. Some of these style guides have special rules. On the Databricks style guide, there's the special rule of 30, that a method should contain less than 30 lines of code in general, and a class should contain less than 30 methods. It makes sense. It's not present in the other style guides. Some of the guides mention, for instance, that local names should be short or can be short. Not all of them mention this. If you look at spacing and indentation, they're all going to agree on a 2-space indentation. And if you want to use something like a 4-space indentation, that's okay, as long as you're consistent throughout your code. But if you go and look at each of those guides, they're going to have further information. Some of them are going to explain what you should do for parameters that don't fit a single line, stuff like that. This was the only occasion so far in every single language that I found someone saying that you shouldn't use vertical alignment. Before I read this style guide, I believed that vertical alignment was a good thing, and I still do. But they make a very good point of why it might be bad for you. And it might make sense in a lot of cases. If you go to Effective Scala, you get stuff like blank lines. If you go to the PayPal Scala style, add a new line to the end of each file, it makes sense. It's not present in the other style guides. So my point here is that there are different style guides. None of them is right or wrong. They will all probably approach right, but you should look at everything and jump to your own conclusions. And speaking of conclusions, what I really want you to take from this is that best practices do differ from language to language. You can learn a lot from the other languages. And they even differ within the same language, sometimes within the same company. And you can learn a lot by looking at what others are doing. You know, we learn a lot from mistakes, but no one says that you don't learn a lot from mistakes that other people did. And you can also learn a lot from what other people are doing right. I'm adding here just a few links so that later on the slides you can jump to some other stuff. And do remember to rate this session. Thank you very much. We do have a few minutes if anyone has one or two questions. If not, I can tell you that one of the best questions I got asked so far was, what happened to the developer who lost 180,000 euros? And I can tell you that he didn't get a raise. He was kept on the team, obviously, and our CEO, after 20 years with the company, he finally moved, he started his own company, And out of a technical team of over 200 people, he chose just 15 developers to take with him, and that was one of the guys. Sometimes it's not about the mess you make, it's how you deal with it. So if there are no questions at the moment, I will be outside. I will have a deck of playing cards with me, and I'll meet you around. Thank you.